Recording in progress.
Beautiful. Okay, welcome back to Nick's Algebraics. With me today, I have three very special guests. We have Random Guy,
You know me already. Hopefully, if you saw the other videos anyway.
and we also have Peanut Butter Brother.
What's up, guys? We're back. We're here.
And lastly, we have Ziggle.
That's good.
I was in the previous video, but I'm back for more.
He's back for
Yeah.
more. He couldn't resist. He
Yes,
needed a piece of the pie.
Eat the pie. No, I need to learn how to stack my pie. That's what we're doing today.
Sorry, he wanted a piece of the cream. My bad. That's what
Yeah,
he
I
wanted.
had to learn how to stack my pie and cream.
Anyway, continue, Nick.
of course. So today I'm going to talk about the disc and washer methods. Let's just do a brief review of geometry before we get into the calculus. In geometry, you were probably taught how to find the volume of different solids. In general, if you want to find the volume of a prism, then that's just the product of the area of the base and the height. So volume is just the area of the base times the height. All right.
Va?
Yep, good old Va. So let's use this for example one. So what is the volume of the cylinder in terms of pi? We're going to use this formula here. So volume is the area of the base times the height. So what is the base of this cylinder?
That would be a circle.
Yes, this is the base. And what is the area of that base?
I'll give you guys a little start here. The area of the base is actually the area of the circle, which is the base. So that's the area.
Which is pi r squared.
Yeah, there you go.
Yeah.
I was leading you to the water. You know what I'm saying? You can't force the horse to drink the water. You gotta lead it to the water.
Thanks for calling me a horse.
You're welcome.
Now his pronouns are kilograms, pounds.
It's W reference. W reference. You
Yeah.
guys won't get that, viewers, but something we were talking about before. Anyway, Nick, continue.
Yes, so you're right. The area of the base is just the area of a circle, so it's just pi r squared. So the volume of a cylinder is pi r squared h. And we have r, we have h, so we just got to plug it in and we'll have our volume. So what is r?
3.
3.
Yeah.
Get your units.
Yes, of course. We have to include units, so 3 centimeters, and we're squaring that. And then what's the height?
8.
Yes, 8 centimeters.
Why was 6 afraid of 7?
Why?
7, 8, 9.
Wow, that's
I feel sick. I feel sick.
a knee slapper.
Wow, unbelievable.
So
72 pi.
yeah, 3 squared is 9, and then times 8 is 72, and square centimeters times centimeters is cubic centimeters. So we have 72 pi cubic centimeters.
Indeed.
So that's the volume of this cylinder in terms of pi, of course. Okay, so the problem is in calculus, the cross-sectional area is not constant. Like you can see for this solid right here, at different slices, the cross-sectional area is different. So since the cross-sectional area is not constant, we can't use V equals A times H because, like I said, A is changing depending on where you are. So the problem is, how do we find the volume of a solid where the cross-sectional area is changing?
Idea.
Yes. What do you think?
Well, as you can see, as you go more towards the x-axis, the radius is increasing. So, like, we need to have like a function for a radius, and then do this on it.
I was thinking the same thing.
That's good, yeah. So let's say we have a function. This is our function right here. It's the graph of the function. And this is f of x equals the square root of x.
The radius depends on x, it seems.
Yes, that's absolutely right. So what I'm going to do is I'm going to rotate the region about the x-axis. Okay? And this will create something called a solid of revolution. It'll create this. A solid of revolution.
It's like a solid, and you like got it by revolving.
Exactly.
That's so solid, bro.
It's very solid. So
Oh, solid. Absolutely rock solid.
It's revolutionary, even.
Very revolutionary. But yeah, solid of revolution is the three-dimensional figure that's formed by revolving a region about a line. That line is called the axis of revolution. So when you rotate this region about the x-axis, you're going to get this solid. So this function defines the shape of our solid. And if you don't believe me, I actually have a video showing the rotation.
Okay, that's good because I usually don't believe you if I can avoid it.
Oh, that's actually kind of cool. Where'd you get that video?
I got it from CalcPlot 3D.
You can do that?
Yeah.
Yeah,
It's like a ham.
Sugoi.
it does look like a ham, kind of, yeah.
Oh, I'm hungry. That's not fair.
It looks like a nice succulent piece of meat, kind of, in my opinion.
Yeah,
That's what I'm thinking. You know,
yeah, I agree.
Yeah.
Indubitably.
indubitably.
So yeah, this is the solid that's generated. And notice how, of course, it's not a perfect cylinder. Like I said
Yeah.
earlier, the cross-sectional area is not constant. So to find the volume of this solid, we first need to cut the solid into thin slices like this. And these slices are perpendicular to the axis of revolution. So the axis of revolution is the x-axis, and we're doing these vertical slices.
It's just sliced ham over a spit.
Pretty much, yeah. And notice how each slice is approximated by a cylinder, right? All of these are just really skinny cylinders.
Discs, you could say.
Yes, you can call them discs. Now, if you take a small slice of this solid at some point x, let's say, the thickness of that slice is going to be delta x, right? Let me pick a random slice, like this one right here. The thickness is delta x.
Yes.
So the volume of a slice is going to be the cross-sectional area at x times the height of the disk, which is the thickness, which is delta x. All right. To get an approximation of the total volume of this solid, then we need to sum up the volumes of all these thin slices at multiple points.
Summing up, you say?
Yes, summing up, that means we're going to use summation notation. The volume,
Sigma.
yeah, we need sigma in here. The total volume is approximately equal to the sum, that's sigma right there.
So Sigma.
Very sigma.
It's Ohio.
Shut up. No more brain rot.
K, we're using K.
Yeah, I'm going to use K because
Yeah, you got a problem with that, random guy?
I
Actually,
actually thought you have a problem with that.
so this is what we get when you add up the volume of each slice. So we're doing it from K equals 1 to N, and N is just the number of discs we have. So in this case, N is 12 because we have 12 discs. All right, so this is how you get an approximation of the total volume of the solid. And
Does the number n matter? Can you make that number anything?
yeah, well, N has to be like a whole number, pretty much.
The larger it is, though, the more accurate, right? Because like you're getting more and more slices.
Exactly. So this approximation becomes better and better as N approaches infinity because
Almost as took the limit as an approach to infinity.
exactly. So what
Taking the limit of the summation. Ooh.
No, don't go there. That's
I'm not
math.
ready.
That's yucky
No.
math.
Yeah, pretty.
I'm not a theoretical math major.
Yeah, it's pretty
I don't need to
sketchy.
go there.
But yeah, random guy's right. We define the volume as the limit of this sum as N approaches infinity. But
Could you say that again? Sorry.
yes, we define the volume.
No, not that.
No, it was the previous
What
one.
about being right? Say that part again.
Oh yes, random guy is absolutely right.
Wait, I glitched out. Can you say it one more time?
Let's move on. So yeah, we're going to take the limit of this sum right here as N approaches infinity. And we recognize the limit of this sum as a definite integral. That's literally the definition of a definite integral. So this right here, when you slap on the limit, it's going to become V.
Yeah, you slap that limit on that hand.
Yeah, so
Oh,
it's going to turn into this.
yes.
It's not going to turn into it so much as that that's just kind of like a representation of what it already is, right?
Yeah, this is what it,
When you take n to infinity, yeah.
yeah,
When you take into it. Okay.
yeah, the limit of this as n approaches infinity is this.
Indeed.
It just,
Nick loves showing all of his steps, but he left out the limit.
yeah.
Yeah.
He'll spend 2 hours on a graph in various different software, but he won't write the limit.
Yeah, I'm not going to write the limit, guys. It's okay. Just trust me. So yeah, this is the formula for volume in general. When the cross-sectional area is changing, you got to use this. All right. So
Yes.
since we're using disks here, what is A of X?
Well, that's like a thin little cylinder, so it's not mathematically distinct from a cylinder, you might say. And
Yes.
upstairs already, we kind of did that. It was like pi r squared times height, except r depends on x now.
Yes.
I'm just saying the area. So the cross-sectional area is just pi r squared. And r is a function of x. Let me
It's
just,
pi x squared. So a as a function of x is translated to pi x squared. A of pi x squared.
Well, I get it's like r of x.
yeah, I was going to say r of
Or R of x. R of x. Yeah.
Yeah, R of X. Yeah.
So for disks, A of x equals pi times r of x squared because r is a function of x. So I'm just going to replace A of x with pi r of x squared.
Height is just a constant. For those who like to pull those out, I would empathize with that point of view.
Yes.
Yeah,
mean,
let me actually do that. I'm just going to pull the pi out. It looks a little better to me.
yeah, get the pi out of that ham. They don't go together.
Yeah.
We should just write it numerically.
Yeah, we should just write 3.14 every time.
Yes.
No. We just got to write the whole thing. The whole 3.1459265, etc.
58979323846. Blah blah blah.
264 950.
288 41971.
Just write 3, actually. Why even go that far? Just write 3.
Exactly. Yeah. Just write P.
Yeah. Yeah.
Oh yeah, we'll translate it to linear algebra. We'll write it as S.
Indeed.
Anyway, so this technique is known as the disk method.
I never could have guessed that.
Yeah.
No, you couldn't have.
Can we call it the ham method instead?
Let's call it the D's method. I like that.
No, I think the ham method is better.
Let's call it the Sugma method. I like
It's a little specific with the square root function, but still.
Yeah, I gotta be honest, peanut butter brother. Sigma is like crappy Sigma, and it sounds very Ohio. So
I'm not. It's W. Dude,
that's an immediate veto.
it's W Duke Dennis Riz, bro. What are you talking about? It's literally from dude, it's imbued with red 40.
Is that?
It's imbued with Sigma red 40 juice, which means that it's Skibbity Ohio W Riz.
I can't even follow this.
Itch my ears after hearing that.
Anyway, Nick.
So yeah, this is known as the disk method, and the disk method is most effective when the region being revolved is in direct contact with the axis of revolution. So notice how this region right here, it's in direct contact with the x-axis the whole time. So
The ham is completely skewered on that spit with no wiggle room.
Are you going over an example where the region is not fully in contact with the graph?
Yes, we'll do that in, I think, example 4, you'll see that.
An example 4.
Okay, let's do example 2. So find the volume of the solid obtained by rotating the region bounded by the curves y equals the square root of x, y equals 0, and x equals 1 about the x-axis. So that's literally what we have right here. We have square root of x bounded by y equals 0, which is the x-axis, and x equals 1. And we're rotating that about the x-axis. So let's actually use the disk method. Let's use this right here to find the volume of that solid. All right. So we need the radius function. We need r of x. So does anyone know what r of x would be for this solid?
Well, the radius is just like the height above the x-axis, so that's just like the y value. So the height, the radius, in other words, is just y, which in this case is the square root of x.
Yeah, the distance from the x-axis to the outer edge of the solid is just square root of x. Like random guy said, it's the y value, and the y values are the square root of x. So that's r of x. It's just the square root of x. And we're integrating this from 0 to 1. All right, so the integral from 0 to 1 of the radius function, which is square root of x, and we're squaring that.
That was a clean square root.
Yes,
Yeah.
thank you.
You're welcome.
That's-
What editor are you using?
I'm using Notability.
WRIS.
Yeah, I love it. I've been using it since 7th grade, so this is like my life.
So you're a pro.
I guess you can say that.
Yes, you're a pro Notability user.
Absolutely. I used it before there was all this crazy subscription stuff, so I'm able to avoid all those fees because I was grandfathered.
You have it for free. So you're using it for free?
Yep. I mean, there's like a couple features that I can't use that I actually need the subscription for. Like the subscription people get to like select all their handwriting and it converts it to LaTeX.
What? What?
Yeah.
That's kind of cool. What?
Yeah. So I'm not able to do that.
It is not sponsored though, is it?
Hold on a second. How much is a Notability premium subscription?
No,
I-
we're not doing free sponsorships. Not until they come and pay us.
Hey, Notability, come sponsor, man.
Yeah.
Come show some love.
I
Can we
believe.
get free subscriptions if
I've been using the wrong freaking program.
What do you
Wait,
use to take notes?
it's $15 per year for the premium plan?
That's right.
That's nothing.
He said, that's right. This is
Guys,
sponsored. This has to be
free
sponsored.
advertising.
Notability, sponsor me.
Yes,
I swear to
sponsor
God.
us,
What-
please.
But you gotta send an email to the company.
I must now.
At
But
this point, you have to.
wait, do you use like Good Notes or something?
No, I use the Freeform app that Apple released.
Oh, the Freeform. Oh,
Freeform
Yeah,
app.
he uses the freeform app.
Totally.
It's gonna be like a-
It's like really malleable, but it's not. It's like it's very universal. It's not specifically good for one thing. Like Notability is probably really good for writing math notes specifically.
exactly. Yeah,
Yeah.
all my math notes in college and all my tutoring lessons, I did it all through Notability.
Everybody hates sponsorship sections, and we're not even getting paid for it.
Anyway, back to the
I solved it first.
It's the integral of just x, the square root.
No,
of- cancel.
just let it happen.
let me cook. So we're gonna
Exactly.
Let him cook. Let him cook.
so the square root of something squared, like squared is gonna undo the square root. So you're just gonna be left with pi times the integral from 0 to 1 of x dx. What is the integral of x?
Well, you just use that reverse power rule.
Exactly.
Yes.
It's power rule.
And we got to put FTC part 1 in there.
Yeah. If you add 1 to the exponent, it becomes squared, and then you divide by that new exponent. So you get x squared over.
Pull that 1/2 out though.
It's okay. It's not gonna.
No, I don't think I will.
Pull it out.
Nah.
Pause.
I don't pull out.
No, he doesn't. I don't. He's gonna do his own thing. Okay.
Yeah. So, we got to plug in 1 and then we plug in 0. So if you plug in 1, that just becomes pi times 1/2, which is pi over 2.
I
And-
can't believe the notation you're using.
And if you plug in 0, you just get 0. So minus 0. So you're just left with pi over 2.
Liberal random guy gets triggered by Sigma Nick conservative amazing writing.
I like
Got like there's a line you're missing in this. Whatever.
Be quiet, libtard.
that. What
What?
what line am I missing?
Never
What?
mind. Never mind.
What?
If I took out the 2, it wouldn't really make a big difference.
Not that line. Never mind. It's just the way you do your definite integrals. You have the brackets, and then there should be another. Whatever.
I have a okay.
He's triggered.
Whatever you say. But let's do example 3 now. Example 3 says, find the volume of the solid obtained by rotating the region bounded by y equals 4 minus x squared, x equals 0, and y equals 0 in the first quadrant about the y-axis. All right, so the first thing you should do is graph this. So does anyone know what y equals 4 minus x squared looks like?
It's just it's like a parabola. You translate it for up, and then you like.
Yes. You reflect it. Yep. Don't forget that.
Yeah. that 4 is going to shift the parabola 4 units up. So let me just put that on my y-axis. So the y-intercept is 0, 4 right there. And that negative is going to flip it. It's going to flip the parabola. So it's going to be concave down. And the x-intercept is going to be 2, right? Because if you set y equal to 0, we know that 4 minus 2 squared is 0. And I can plug in 1, and you'll get 4 minus 1, which is 3. So I have those 3 points. And I'm just graphing the right half of this parabola because the problem says in the first quadrant, and we're bounded by x equals 0, which is the y-axis, and y equals 0, which is the x-axis. So you don't have to graph the whole thing. All right, and we're rotating this about the y-axis. All right, and let me also shade in this region.
Da, 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 da.
Like, is there not a fill function?
No.
Okay, good job.
Yeah, let me actually
So pretty.
let me make it red.
Horrible.
Bro, stop.
So there is
Green was better.
green is better. Okay, we'll go with green then.
Yes.
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 This shade of green is much better than whatever gray you put in.
That's the most colorblind thing I've ever heard. So, but there is a fill function, by the way. If I like drew a rectangle and I wanted the inside of that rectangle to be highlighted green, I could do that, but I can't do that here because it's like this half parabola and it's not like closed, so it doesn't know where to stop filling it.
Indeed.
Yes. So notice how the axis of revolution, which is the y-axis, is vertical. This changes the setup of our integral. This is because the slices are now perpendicular to the y-axis. Like if you were to revolve this, the discs are going to look like this. Yeah, so you're going to have these horizontal slices that are perpendicular to the y-axis. So the radius of each slice is now a function of y, not a function of x. So we have to express everything in terms of y.
I
So,
prefer my orange slices vertical. Thank you.
yeah, but yeah, the thickness of each slice is not delta x anymore. It's now delta y. And the radius is now r of y instead of r of x. So yeah, everything's going to become in terms of y now. So the integral is going to look like this. V equals pi. And instead of x1 to x2, now it's y1 to y2. And instead of r of x squared, it's now r of y squared. And instead of dx, of course, it's going to be dy. So this is what we have to use now. We don't have r of y, though. So we need to find the radius as a function of y. So we know that y equals 4 minus x squared. So I need to solve for x. So I have x in terms of y. So what do I need to do to find x?
We can add the x squared to both sides, subtract the y, you square root it. No need for a plus or minus since we're in the positive x side. And that's how you do it.
Exactly.
Exactly. Yeah. Good job.
Oh, still clean.
Yeah.
The little self-correcting thing is so nice.
Yeah.
Must not be a premium feature.
Yeah. I think the free users get it too. So we're not doing plus or minus again because we're just doing the right half. And like all the x's are greater than or equal to 0. So this is our radius function. It's a function of y now. So
Yeah, because the x value gives the radius.
Exactly. This is the x values. These distances are the square root of 4 minus y. So let's plug that in here. So this equals pi, and we're integrating this from 0 to 4. And r of y, so that's this, and we're squaring it, dy. So just like last time, the squared is going to cancel out the square root. So you're just left with pi times the integral from 0 to 4 of 4 minus y dy. So what's the integral of 4?
For y.
Exactly. And what about
Good job. There you go.
the integral of y?
Reverse power rule.
Yeah. So y squared over 2. we need to plug in 4 and then we got to plug in 0. So if you plug in 4, we have 4 times 4 right here. That'll become 16. And then this is 4. It's 16 over 2, which is 8. And if you plug in 0, all of this just becomes 0. So just a minus 0 here. So 16 minus 8, that's 8.
Right.
Yeah, good job. So
You get a gold star.
yeah, you're a good noodle.
Hey, yo. He has a good noodle. That's sus. That's major pause.
So
Can we calculate the volume of the noodle using this method?
Yo, pause. He's meat watching. Viewers at home, random guy is in fact the meat connoisseur.
That's all on you. That's all on you. You're the one getting these videos age restricted.
None of them are age restricted, boy. What are you talking about?
Not yet.
yeah, not
I
yet.
guess.
Okay, so yeah, the volume is 8 pi. Let's do example 4. So same idea, find the volume of the solid obtained by rotating the region bounded by y equals x squared, y equals 4, and x equals 0 about the x-axis. So again, let's graph y equals x squared. This one's pretty easy to graph. Let me just put some numbers on the axes. So we know at x equals 0, y equals 0. At x equals 1, y equals 1. And at x equals 2, y equals 4. And that's good enough because we're bounded by y equals 4 and x equals 0, which is the y-axis. And let me put a dashed line for y equals 4 right here. Let me also shade the region. So we're rotating this about the x-axis, rotating this region. So notice how there's a gap between this region right here and the axis of revolution, which is the x-axis. There's this gap here.
I do notice that, yeah.
So we cannot use the disk method anymore because the slices of this solid are no longer simple disks. So instead, these slices are disks with holes in them.
Washers.
Yes, those are known as washers. You can see like it's going to look like that. Okay, that's the best I can do for now. But yeah, there's going to be a hole in this disc basically, which is known as a washer. So
Goes to church on Sundays. It's holy.
Oh my god. Oh, shut up. Excuse me. Continue on me.
of course, not a problem. So remember, in general, to find the volume of a solid, you just take the integral of the area, right? And I'm doing this in terms of x because we're revolving it about the x-axis. So this is, in general, how you find volume, just the integral of the area.
Integrate with respect to the variable that's like the name of the axis.
For disk and washer, yeah. Well, if you're rotating about like y equals 1, I mean, it has y in it, but it's horizontal, so you still have to do it as a dx integral. So if you have a horizontal axis of revolution, then you're going to have everything in terms of x for the integral. And if you have a vertical axis of revolution, you're going to have everything in terms of y for the integral.
Just asking like, people that want to know, you know, when you do these types of problems, knowing which way to do it is how to set it up is always the hard part.
Absolutely. So we need the area function. We need to find the area of washers in general. So this is a washer right here. Like I said, it's like a disc with a hole in it.
It's just a circle minus a smaller circle.
Yeah. So let's say the radius of the outer circle is capital R of X. And let me do that in blue, actually. And
no one cares about the colors.
I care. So
He cares. You fool.
and the inner radius is lowercase r of x. So capital R of x is the distance from the axis of revolution to the outer edge of the region. And the inner radius is the distance from the axis of revolution to the inner edge of the region. But yeah, to find the area of the washer, we need to subtract the area of the inner disk, which is the hole, from the area of the outer disk. So let's plug that into the area function. So this is going to be pi times the outer radius squared minus pi times the inner radius squared.
If you just distribute the integral, you're basically just subtracting two different disk volumes.
Yeah, exactly.
Yeah.
I mean, it's not really even a new method if you think about it.
Yeah, it's
It's
not.
not. It's not.
Yeah. So, and then I can just take out the pi, actually. Let me just do that. We can just write it like this with the
I
pi.
was wondering why you weren't taking it out.
I like to write it like this. So, yeah, we can take the pi out and it looks a little cleaner like that.
You ordered the pie for takeout?
Yeah, there you go. Yeah, I took it for takeout.
Oh my God.
I'll do better in the future, I promise.
Yes, you need to be random guy. Otherwise, I know where you live. So
Oh,
sorry. I'm sorry. Anyway,
yes,
Nick, please continue.
of course. So this technique is called the washer method. And the washer method is most effective when there's a gap between the region being revolved and the axis of revolution, just like what's happening here. Now, what is the outer radius? Remember, outer radius is the distance from the axis of revolution to the outer edge of the region. So what's that distance?
Ziegler, you want to take this one?
Did you say ziggle?
Yeah, sorry, Ziggle. My
Oh
bad.
wait, did you just use ziggle with the hard R? That's crazy.
I'm
Not-
offended.
You do
can
not
take
have the
this one.
pass. You do not. He
For the
doesn't
record, you gave me a pass, and that wasn't me using it. But
he just ziggled you.
anyway,
And-
you want to answer it?
So
That's ziggle.
No, I apologize. I was distracted because somebody was texting me.
not a problem.
It's a sneaky link, guys. Sorry. It's okay.
But that looks like a yx squared if you want to answer it.
Are we doing washers?
Yeah, I'm saying what's the outer radius? And I said, remember the outer radius is the distance from the axis of revolution to the outer edge of the region.
Okay, so that's just y.
That would be,
Equals 4.
it would be y equals 4, yeah. Y equals x squared, that would be the inner radius.
Yeah, that's what I was thinking. I got them mixed up for a second.
Yeah. No, I was very disappointed in that. I thought I touched
Bad.
Yeah, not a problem. So the outer radius, the capital R of x is 4, and the inner radius is
Did you ask me for the inner or the outer?
the outer.
So I got it right. Okay, cool.
You got it wrong. You said y.
He didn't finish speaking. Let the man cook.
Oh, you didn't say
Exactly.
equals 4. Oh, okay.
He was so distraught by random guys' use of Ziegler that I have the pass. So of Ziegler that he forgot to say the rest of it. So.
Yeah, it's okay, guys.
My bad.
It's okay. We all have oopsie moments. It's okay.
Yes.
And we're integrating this, from 0 to 2 because it's a dx integral. Everything's in terms of x. So integral from 0 to 2. Again, outer radius is 4. It's constant, so 4 squared minus the inner radius, which is x squared. And we're squaring that. So 4 squared, that's just 16. And x squared squared is x to the power 4. So what's the integral of 16?
It is.
In times.
Yes. There you go.
X.
Good job. There you go.
Yeah, 16 times x. And then for x to the power 4, what do you get for the...
Reverse power rule.
How about someone else answer? What's the... Yeah,
Ziggle, you stole my response, you stupid Ziegler.
You're just like my teachers. Like, oh, let someone else answer.
You filthy stupid Ziggle.
Wait, okay. I admit that I stole your spotlight, Mr. Peanut Butter Brother. So I would like to give you the opportunity of a spotlight in the video. So I'm going to ask you, can you explain how the reverse power rule works?
I could, but my student here, random guy, I don't want to give him all the answers. So you know what? I want him to explain just so that he, gets better. I want him to improve at this and really, really lock in that muscle memory. So go ahead, random guy, explain it.
Yeah, while Nick does the arithmetic there, I'll just talk over it.
I think, and I hate to interrupt you, random guy, but I know that you are fully capable of explaining this, and I just want to exercise getting Mr. Peanut Butter Brother some extra help.
Okay, well, how about this?
And ensuring that his confidence remains at an all-time high because I spoke over him.
How about this? How about we send all you little Zigglers back to your own land? How about that? Instead of you guys
it's Ziggle,
picking up all our jobs and doing crimes and shooting the crime rate. You guys are 13% of the population, but you commit half the crimes. How does that work? Explain that to me. You need to get out of this country. You're white and blue.
Anyway,
Might be.
you raise to the exponent, add 1 to it, you divide by that number. That's how reverse power
Indeed,
works.
indeed. Yes.
Meanwhile, Nick solved the arithmetic part of it.
I knew that, but I just didn't want to explain it that simply. So I was like, oh.
So you just plug in 2. This becomes 32. And then 2 to the power 5 is 32. And then you divide that by 5. And when you plug in 0, this whole thing becomes 0. So you just have a -0 out there. And when you do the arithmetic, you get 128 pi over 5 for the volume. All right. And here's a table summarizing everything I just talked about. So in general, if you want to find volume, you take the integral of the cross-sectional area. And
Yes.
if you have a horizontal axis of revolution, everything's in terms of x. And if you have a vertical axis of revolution, everything is in terms of y. And then for the disk method, the cross-sectional area is pi r squared. So a of x just becomes pi r squared, and I just took the pi out. And then same thing for a vertical axis of revolution, it just in terms of y. And for the washer method, it's just a disk with a hole in it. So you have to subtract pi times the inner radius squared, but I just took the pi out. And it's the same idea for vertical axis of revolution, but it just in terms of y. So if you understand what's going on, you don't have to memorize these. It's all just like pi r squared. It all goes back to the area of a circle. Okay, so there's nothing to really like memorize here if you really understand what's going on.
You know, the more calculus you learn, the more it becomes apparent that you're just learning more and more complicated ways to do addition.
Pretty much.
Lucky.
Okay, so now that we have this summary in mind, let's use this for the next example. Find the volume of the solid obtained by rotating the region bounded by y equals x squared and y equals 2x about the y-axis.
Y-axis, that sounds like a dy type of situation.
Exactly.
We should graph these.
Yeah,
We should.
first thing you should do for these problems is graph it so you can see what the region looks like and what you got to do from there. So let me just put some numbers.
What you gonna do? What you gotta do when it comes home?
Exactly.
Copyright strike. Struck. Copyright struck.
Video's gonna get struck down.
Stricken from the record.
Exactly.
I'll strike you from the record.
Ooh. Me personally, I'm never letting that slide.
I will strike the coconut oil off your face before you can strike me from the record.
That's racist.
That's racist. Oh my god.
I don't want to do a race reveal in this video, but why don't we graph 2x?
Yeah, why don't we let's come back to the problem. So I graphed y equals x squared. It's the same thing as last time. So 0, 0, 1, 1, 2, 4. And if you graph y equals 2x, that's just a line that goes through the origin and it has a slope of 2. So 0, 0, and we go up 2 over 1, and then up 2 over 1. So you get this line.
Looks kind of like an airfoil.
What is that?
Or is that an aerospace, I guess?
No.
Yeah.
No, it doesn't look like that actually.
Yes, it does. Yes,
It looks like it looks like a banana, pointy banana.
We forgot to
No,
use
if you were to rotate that negative 130 degrees, it would look deliberately like an airfoil.
No, it actually looks like Tinkerbell's wing actually, rather than a silly
a
air
wing. Yes, thank you. It's a wing.
No, wrong. Banana. See? Yeah, Nick agrees with me.
It does look like a banana to me.
What kind of bananas are you?
You look like a banana.
Oh my god. That's so racist, Ziggler. You can't do that.
Ziggle.
I mean,
No R.
I apologize. I didn't mean to offend you and your people.
Anyway,
I think we're using washer for this because it's not bound like to the axis exactly.
yes.
Touch it.
Only
It
graphing.
tickles the origin.
Oh, you're saying it touches the axis of revolution at the origin?
It tickles it.
It it does, but there's still a gap here, so it doesn't count. But again, I'm only graphing like the stuff in the first quadrant because that's all we need. That's what we're revolving about the y-axis. All right, so like I said, there's a gap here between the region and the axis of revolution, so we have to use the washer method here. And we have a vertical axis of revolution, so the integral is going to be in terms of y. All right, so we're basically doing this right here. So let me write that out. So v equals pi times the integral from y1 to y2 of r of y squared minus lowercase r of y squared dy. So we want the radius function, and it has to be a function of y. So what is the outer radius here?
Y equals 2 and y equals -2. X equals 2.
No, there's no like region here.
Ziggle, you said it was so easy before we started the video.
Yeah.
I don't know what you're talking about.
It is. He's just testing you guys. Like he's making sure you
Exactly.
understand. He's not, dude. Come on.
Do you guys want to see on CalcPlot 3D what the solid looks like?
No, I don't.
Yeah, I do.
X squared.
I would also like to see it on CalcPlot 3D because I tried to use that thing and it is confusing.
Okay, so we have,
You have to type in squirt to get the square root.
yeah,
You have to type.
That's how you know it's
Right.
made. It should have like that, like the Desmos type.
That's how you know some college kid wrote this.
Yeah, because they just wanted to see people type in squirt.
Like this is like Wolfram Alpha. Actually, not even.
No, not at all. Wolfram Alpha is like more. It's not really sus. Like this is like sus, and Wolfram Alpha is like Baby Grunt, kind of like rizzing up Libby Dunn, in my opinion. But that's just me. I don't know. What do you guys think?
Well, so it's a beautiful airfoil.
you see
No,
that?
it's not, bro. Baby Gronk wouldn't say that. So what are you talking about?
As I predicted, clearly the parabolic part is like the outer shell.
No, it's not.
Like X squared is the outer.
Yeah, you can see the inside too. It's like a bowl kind of.
It's like Libby Dunn.
So the outer part is the x squared part, and the inner part is the 2x.
That's enough
Inner
math plotting.
Or actually, let me go back to the region.
I'm so traumatized by the cinch graphing from the hyperbolic video that I don't want to see any more graphing.
That gave him PTSD.
So
It's traumatic Nick disorder.
yeah. You see these washers right here? You see how the outer radius goes to the x squared and the inner radius?
This is so fancy.
Yeah. Let me zoom in a little, like there. So you see those washers there? Let me actually do it with...
As X approaches infinity is her when she says it's her first time. I'm sorry. I apologize.
Not a problem. So this is with 17 washers. And yeah, as you get more and more washers, you get closer and closer to the actual volume of the solid. So
why are we reviewing the washer method when we're on the other next example already?
Because he wants to, you buffoon. No, I'm just kidding.
my heart desired it. You know, I think this lesson just speaks volumes. Don't you think?
Stop it. That was horrible.
That was a solid fail.
Yeah, it's
Get it?
I'm sending a squad to go commit arson on your home as we speak.
He has the authority. He's a revolutionary figure.
We're gonna get Peanut Butter Brothers' brother to dox you.
Oh.
Indeed, we are.
Anyway, let's go back to the problem. So the outer radius is this right here. So it's y-axis to x squared, but we want everything in terms of y. So I don't want to write x squared for the outer radius. I have to solve for x. So I'm going to get x equals the square root of y.
No plus or minus needed because of the quadrant we're in.
Exactly. This is just the right half of the parabola, so it's just square root of y, not plus or minus. And same thing for the 2x. The inner radius is the y-axis to 2x. But again, we don't want to literally plug in 2x for the inner radius. We want it in terms of y. So I have to solve for x. So I just need to divide by 2. So x equals...
Wait, why did you say 2x again?
Why? This is the inner radius?
Yeah.
Because...
So what were we doing in the calc plot?
Didn't I just talk about that for like 10 minutes? But
yeah, that's the whole point of the plot. It's like because the parabola was like the outer part of it that you saw, and like when you look at the inside of the bowl,
and then the other one's the inside.
Yeah,
like
it's like what are you going to be subtracting from what?
Indeed,
like you're cutting. What are you cutting from what? You're cutting out the region formed by the 2x out of the parabola. So that's why.
Right.
So like here, this is like the washer we have.
Oh, no, not more graphic.
Here, that's our washer. And you see how the inner radius is y-axis to 2x, and the outer radius is y-axis to x squared.
Mm.
Yeah. So
Why specifically 2?
that's what the
Oh.
problem said.
Yeah.
Oh, I missed it.
Oh, you were just asking why we're doing 2. Oh, yeah, that's literally what they gave us in the problem. Yeah.
You wrote the problem.
Well, what
Wait, you wrote the problem.
I keep saying they as if like someone else wrote it, but yeah, that's what I put in the problem. Anyway, but like I said, we're not going to literally plug in x squared for the outer radius and 2x for the inner radius. We have to solve for x because we want everything in terms of y. So we're going to integrate this from what to what, guys?
I'm gonna integrate it from
Y equals 0 to y equals 4.
Exactly. It's in terms of y.
Revolutionary idea, no pun intended. What if instead of worrying about which is the outer and inner function, we just like didn't care and did it normally and just took the absolute value of whatever you got because you know the volume is going to be positive.
that's wrong.
Like who cares what's big R and what's little r? Just subtract one from the other. You don't care. The integral will be positive or negative. You just take the absolute value
Of your answer?
Yeah.
Okay.
That's low
That-
key.
if
That
you-
works.
If you switch these two terms, you'll get the opposite of the answer, and then yeah, you can.
Wait,
Okay.
all the calc students out there, make your teacher angry by using a pen.
Yeah, guys, actually don't do that because
We're
I,
always
No,
finding-
do that because that would be funny. It's like
no,
extra work,
don't do
but
it because otherwise I'm coming to your house.
We love
Okay.
to take shortcuts.
No, actually, some people would want that. Never mind.
you would have wanted that. So yeah, I don't want to hear people.
What? No.
Yeah, back in your Harvard days.
Yeah, that's true.
Fellas, it is time to do this integral. So what's going to happen with the square root and squared?
What's gonna happen is they're gonna cancel each other out because guess what? That's what happens when you have that. You know.
Cancel culture.
Yes.
1/2 y squared minus y cubed over 12.
Yes, you can pull it out.
When in doubt.
The integral of y becomes y squared over 2, and the integral of y squared over 4 is y cubed. And when you divide it by 3, you get over 12.
Do you realize Nick has no videos just on how to take derivatives and integrals?
I suppose.
He'll have to make those eventually, but
Yeah.
Those will be like set at a record time, hopefully.
he made a video on the gradient, but he didn't make a video on derivatives.
I didn't make a partial derivative video.
He made a Calc 3 video before he made a Calc 1 video.
Yeah.
He made a video finding the answer to the Riemann hypothesis, but
He
not
has a video
on integrals and
He has
derivatives.
a video from 4 years ago saying how to write equations.
Wait, finding the Riemann hypothesis? Isn't that
That was
supposed to
that was one of his videos. He actually found it in one of his videos, but he still hasn't made a video on derivatives or
Nick's earlier videos are like crazy. It's
My-
like how to do order of operations, solving multi-step equations,
How to add
solve one-step word problems.
My old videos are so easy. It's literally like how to add numbers.
And then just with the volume of revolution video.
wasn't one of them like tutorial how to oil up in twerk.
be? Oh, that's gonna get us canceled.
Or
Gonna get us canceled.
that was I'm just stating the fact. That's one of the
No,
videos
you are
he made.
getting us canceled.
He made that video.
You are getting us canceled.
He made the mathematical formula on how the jiggle works when they're throwing it back.
Peanut butter brother, you're gonna get us canceled.
Just speak the integral.
Yes, let's
Just
do.
solve the integral. 0 to
Let's
4.
solve it.
Just solve it.
Okay, so I'm gonna plug in 4, and I'm gonna plug in 0, and I'm gonna subtract. So if I plug in 4, this becomes 16 over 2, which is 8. Over here, 4 cubed is 64, so that's 64 over 12. And when I plug in 0, this whole thing becomes 0, so it's minus 0. So this is it. And if you do the arithmetic, I'm not going to show it all, but
Thank you. Please.
yeah, I understand that.
Steps, accept limits, but
Yeah. So 8 pi over 3, that's what you get.
Yes.
didactic.
Eat pi over 3.
That's right.
Yes. It whatever he said.
Okay, now let us do the final example of today. This one's a trig
Example.
one.
Finale.
Yes.
I've definitely seen this problem somewhere before.
No, you haven't.
This might have been straight from the textbook. This might have been an exact homework problem Miss Burton gave you guys.
Are you serious?
Teacher name reveal.
So first,
Yes.
we need to, of course, graph this. So let's graph
No.
let's graph 1 plus secant x. And we're doing this from x equals negative pi over 3 to x equals positive pi over 3. So let's figure out what secant of pi over 3 is to start off. Secant of pi over 3, remember secant is 1 over cosine. So this is 1 over cosine of pi over 3.
Which is 1/2. So the reciprocal is 2.
Exactly.
Exactly.
So here, let me put pi over 3 right here and negative pi over 3 right here. So this is just secant of pi over 3, but we're adding 1 to it. It's 1 plus secant x. So
3.
yeah,
The negative is going to be the exact same. Cosine is an even function.
Yeah, the negative is going to be the exact same because it's an even function.
yeah,
Trigonometry review.
yep. That's why I put this problem in.
Tell me I'm right again, Nick.
Hey.
You're right, random guy. You are right.
What is going on? He just sunned you, Nick. I would never let that slide, me personally.
I've never been wrong in a video. If I have, he cut it out.
You
Yeah.
were literally wrong earlier. You mixed up two things.
I don't know what you're talking about.
Oh, he's denying reality. Oh my gosh.
Anyway, we have the ends of the graph. Now let's do secant of 0. What's secant of 0?
1.
It is 1.
Yeah, it's 1 over cosine 0, so 1 over 1, which is 1. And we're adding 1 to that, so you get 2.
2. 1 plus 1 equals 2.
Yes, everything is being used in this video. Again, we have 1 plus 1 equals 2 all the way to geometry to integrals.
0.9 repeating plus 0.9 repeating equals 2.
That's right.
That's right. Good job.
Gold star, you good doodle.
Gold star. Now you get your noodle, never mind.
You earned a gold star. Get
Just
this by a noodle.
You
This
get
is
a
little-
noodle massage.
This video made me so hungry.
I am so
It made
hungry
you
now.
what?
I am starving.
Oh, hungry. Okay.
Oh,
Calm down.
I thought he said something else.
Yeah, I know what you thought he said. Actually, I know what you thought they said.
They said, say them. Da, 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 da.
Bro, what are you putting in this bowl?
Can you
Putting-
pick it?
Putting a mysterious green slop.
yes.
Marker to make it go faster.
I should have used the bigger marker, but it's too late now.
Never too.
So size matters.
I guess you can
Well-
say that.
Wait, is it the motion of the ocean, or does size like the most important thing?
That will be an exercise for the audience.
Yeah, audience, tell us in the comments below. Is it the
Don't do that
motion of the ocean? Size better.
Don't do that exercise. I think we've completed our region. Now it's time to rotate it.
Wrong.
So notice how we are rotating this about the line y equals
Y equals 1.
y equals 1. Yeah.
Well, horizontal.
Yeah, it's still horizontal, so we know this is going to be a dx type integral. So this is what we're rotating about.
Your graph isn't big enough to draw the second half.
It's okay. I'm just graphing the region. I'm not graphing the solid. So,
Fair enough.
so we are going to use the washer method because obviously there's a gap between the region and the axis of revolution. And again, we have a horizontal axis of revolution, so we're going to make everything in terms of x. So we're basically using this right here. So let me write that down. So think very carefully here. What is the outer radius? Again, remember, outer radius is the distance from the axis of revolution to the outer edge of the region. What's that distance right there?
It is 0.9 repeating times 2.
That's right. Yeah. I had to think about that for a second. So
That's true.
the distance is just 3 minus 1. That's the outer radius. What are the bounds of this integral from what to what?
Is from negative pi over 3 to pi over 3.
Exactly, because it's in terms of x. So negative pi over 3 to pi over 3. And the outer radius is 3 minus 1, and we're squaring it. And minus the inner radius. Remember, inner radius is the distance from the axis of revolution to the inner edge of the region.
Into +1.
Secant plus 1.
Well, secant plus 1 is x-axis to secant plus 1.
Oh, you're right.
You drop the 1.
Yeah, so we have to do 1 plus secant x minus this 1 right there, and that'll give us that distance.
Secant, that's what I said.
By the way, I got my answer from random guy, so it means the random guy was wrong. Okay, so
I said
Isn't random guy your apprentice?
he is, but I was testing him and he failed the test, so that means that he was wrong.
I did say just secant. I was right.
Wrong. You said secant plus 1.
Yeah, but then I said -1 after that.
Well, you were wrong first, so that means you're exiled from the stature of secant. I don't know.
Anyway, you're basically doing top minus bottom. So this is 2 squared, so that's 4. Over here, the 1's nicely canceled. And then so you get minus secant squared x dx.
We're going to do a nice integral here. It's going to be tangent on that part. I look forward to it.
Yes. One tiny thing is this right here, the integrand, is an even function. So I don't have to do...
I see.
Yeah, so
True.
I can just, instead of doing negative pi over 3 to positive pi over 3, I can just cut that in half and start at 0 and just double everything. So just put a 2 in the front because the left half has the same volume as the right half. So I can just, you know...
Anyone watching didn't understand that step, just don't do what he just did and do it normally. Negative pi over 3 to pi over 3. Don't do it 2. But yeah, this is the way I agree is a little superior.
Yeah, it's nice to plug in zeros, take advantage of symmetry, exploit the symmetry. So,
Wait, I like that.
So what's the integral for?
For x.
Or x.
Exactly. The derivative of tangent is secant squared. So the integral of secant squared is going to be tangent. So minus tangent x. And we're evaluating this from 0 to pi over 3. If I plug in pi over 3 here, you just get 4 pi over 3.
Minus √3.
Yeah, and tangent of pi over 3, that's just sine of pi over 3.
Please, don't review the unit circle.
Over cosine of pi over 3. Sine of pi over 3 is √3 over 2. Cosine of pi over 3 is 1/2. The 2's cancel, you just get √3.
Yes.
Okay, it was quick at least.
Yeah.
These clean square roots all throughout the video.
Yes. I mean, I've been doing that before. I don't know why you guys are talking about it for this
I
video.
know, I only just really appreciated it now. Sometimes you get hit by realization like that.
Yeah.
I think ziggle noticed it first.
But the 0 is going to cancel
I
out.
noticed it first because I was like, how the heck are you getting them so clean? Because I've tried to do that with the Notes app and the Freeform app, and it just don't work like that.
So when you plug in 0, this all just becomes 0. So you have a minus 0 out here. And honestly, you can just leave your answer like this. It's totally fine.
I would. Yeah.
That's what I was thinking too.
You can distribute the 2 pi, but like it's not really gonna get
No,
you
don't.
anywhere.
If you're
Not
hungry,
necessary.
if you're hungry, you make a mistake. So don't do it.
Yes.
Just like a random guy.
All right.
Like we finished the last example.
We have finished today's lesson. So thank you everyone for joining. And I think that it would be best if Peanut Butter Brother closed us out.
Well, everyone, it has been your boy, Peanut Butter Brother, signing out. Make sure you smash that like button, hit that subscribe button, and ring, ring, ring. Turn on those post notifications so you never miss a video. Make sure to stay updated with all of Nick's content, and we're going to keep making these banger videos for you guys. So make sure you keep interacting, subscribe, you know what I'm saying? You know, show some love, all right?
If you want us to do this live, put it in the comments.
If you want us to start a gaming channel, make sure you put it in the comments too. Or an OnlyFans, then we can do that too.
No.
Yes.
No,
and by the way, random guy.
The OnlyFans would probably be the same as this. We'd just be reviewing things.
Yes, true. Random guy proposed that, by the way.
I
He
did
was,
not. I'm a good Christian. I would never. I
Oh,
would-
random guy, you wanted us to review your content?
I have no such content.
he does. He's a little shy.
Maybe I'll make some.
A little shy.
It's
Okay, but yeah,
it's okay to be shy.
but yeah, guys, we're gonna if you want us to do other kinds of videos, make sure to leave in the comments below. Make sure to subscribe, and yeah, we'll keep making these bangers for you guys. So
Perfect. So I'll see you guys in the next video. Thank you very much.
bye.
Ciao.